science video with me, Mr Goff, for MrGoff.com. This video will focus on network topologies and links between hosts. The physical topology of a network is the way it is physically laid out. At GCSE, we looked at two physical layouts, the star topology and the bus topology. In the star topology, computers and other devices on the network are each connected through a central hub or switch, with each device having its own separate wire. In the bus topology, computers and other devices are all connected to a central shared cable that everyone puts their data on. The bus topology is cheaper to set up than the star topology, which needs additional cabling and a central device. However, because each device in a star topology has its own cable, there is less time spent waiting for access to the main cable, and so a star topology is more efficient than a bus topology. In addition, adding new computers to the network does not put as much strain on a star topology as it does on a bus topology, where those new computers have to also share the same main cable. A bus topology is also less secure than a star topology, because broadcasts on a bus network go to all devices so all devices can see all messages that are sent. On a star network, the hub is able to use the MAC address of the specific devices involved, so only the devices that are trying to communicate see what the communication actually is. The logical topology of a network refers to the way data is sent between devices. On a bus network, each device must request permission to use the shared bus in order to avoid data collisions. We'll be learning more about this in an upcoming video. Also, all data is broadcast to all devices on the network. As we've just seen, a logical star uses a hub so that only the devices involved in a transmission see the data for that transmission. But it can also be set up with a switch and an operating procedure that sends all data to each connected node in turn, in which case it is said to be a physical star but a logical bus. Peer-to-peer networks connect computers directly to each other. This might happen via a LAN or a WAN like the Internet. In a peer-to-peer network, each computer has equal status. They are cheap and easy to set up and maintain, making them ideal for small office or home setups. Larger peer-to-peer networks can be very effective for delivering large files on demand, such as audio and video files. This is because the computer downloading the file can download part of the file from several different peers at the same time, which each have a copy of the file. This reduces the load on any one point of the network. Peer-to-peer networks have been widely used for sharing of illegal copyright content, such as the original Napster. Creators of Napster and similar sites have tried to hide behind the concept that copyright material was actually being hosted on individual users' computers, but all have been considered to be guilty of helping to facilitate copyright infringement. In a client-server network, there are a number of computers referred to as clients that request services from powerful computers known as servers. Clients may have their own software and some local files, but also have access to servers. Servers may include file servers, print servers, web servers, mail servers, and many more types that would be specifically needed in some particular instances. A client-server network has better security than a peer-to-peer network because all files are stored centrally where access can be managed. This also means backups can be managed centrally. It's more expensive to set up and maintain a client-server network. This usually requires IT professionals. That brings us to the end of this video on topologies and links between hosts. Join me in the next video when I'll be looking at wireless networking. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.